Have you ever made your own infused water? It's simple. Add fruit and herbs to water, let it sit, and watch the magic happen. The water looks clear, almost unchanged, but when you take a sip, wow! The flavor is bold and surprising. How does plain water become so delicious without any visible change? It's not magic, it's science. Even when you can't see a difference, amazing things are happening on a microscopic level. Tiny particles from the fruit and herbs are moving into the water, creating that burst of flavor. This invisible transformation is a perfect example of how science works behind the scenes. We're about to dive into the hidden world inside your glass and discover how flavor travels from fruit to water. Get ready to explore the science that makes your infused water taste so good. Put on your science goggles. Let's uncover the secret behind that powerful flavor. There's much more happening than meets the eye. Let's begin our journey into the invisible world of infused water. To understand infused water, imagine shrinking down to see the world of molecules. You'd see water and fruit slices as bustling with countless tiny particles, molecules, constantly moving. Everything, including the strawberry in your water, is made of these molecules. The strawberry holds water, sugar, and special flavor molecules, tiny packages of taste. Our tongues and noses can detect even a few of these molecules. When you add fruit to water, you're mixing two sets of molecules. At first, the flavor molecules are trapped inside the fruit, but they're energetic and want to spread out. Water molecules bump into the fruit, knocking flavor molecules loose. It's like a microscopic game of bumper cars, freeing flavor to move into the water. This is the start of infusion. Invisible particles leaving the fruit and entering the water. The water may look still, but it's alive with motion. That's how flavor begins its journey into your drink. Flavor molecules are special chemical compounds that create taste and smell. Each fruit or herb has its own unique set, like menthol in mint or furaniol in strawberries. These molecules are incredibly tiny. Millions could fit on a pinhead. Because they're so small, they dissolve easily in water and spread out, becoming invisible. Our taste buds are sensitive and can detect even a small number of these molecules. When a flavor molecule fits into a taste receptor, it triggers a signal to your brain: sweet, sour, minty, or more. Even a little infusion leads to a big taste, thanks to these powerful particles. Every sip contains thousands of flavor molecules, delivering a consistent taste. That's the secret behind the strong flavor in your clear water. How do flavor molecules travel from fruit to water? The answer is diffusion. Diffusion is when particles move from where there are lots of them to where there are fewer, until they're evenly spread out. Imagine opening a bag of popcorn. The smell spreads across the room by diffusion. In your water, flavor molecules move from the fruit, high concentration, into the water, low concentration. They keep moving until the flavor is evenly distributed. That's why you need to let your water infuse. It takes time for diffusion to work. Stirring can speed it up, but diffusion happens naturally. The random motion of molecules ensures flavor spreads everywhere. When you taste your infused water, you're enjoying the result of diffusion. It's the invisible process that fills every sip with flavor. Some ingredients flavor water faster than others. Why? Temperature matters. Warmer water speeds up molecular movement, making infusion quicker. Surface area counts. Sliced or crushed fruit exposes more area, letting flavor escape faster. More fruit in less water creates a steeper concentration gradient, speeding up diffusion. Smaller molecules, like those in citrus, diffuse faster than larger ones. Crushing mint or slicing fruit increases surface area and speeds up flavor release. Cold water slows everything down, so infusions take longer. The right combination of temperature, surface area, and ingredient ratio gives you the perfect infusion. Now you know how to control the speed and strength of your flavored water. Ever notice your infused water smells stronger than it tastes? That's because smell and taste work differently. Aromas come from volatile molecules that easily float into the air and reach your nose. Our sense of smell is extremely sensitive and detects these molecules quickly. Taste buds only sense molecules dissolved in liquid, like sugars and acids. Many taste compounds aren't volatile, so you only notice them when you drink. The full flavor is a combination of what your nose smells and your tongue tastes. Try pinching your nose while sipping. Flavor seems duller. release your nose, and the full taste returns. Smell is a huge part of what makes infused water so enjoyable. Diffusion isn't the only process at work. Osmosis helps too. Osmosis is when water moves through a semi-permeable membrane, like fruit cell walls. Water flows into the fruit, increasing pressure inside the cells. This pressure helps push flavor-filled water back out into your drink. Osmosis and diffusion work together. Osmosis draws water in, building pressure, and diffusion spreads flavor out. This teamwork makes infusion more efficient than diffusion alone. It creates a cycle: fresh water in, flavor out. That's why your water gets tastier over time. The invisible dance of molecules is happening in every glass. Science is always at work, even in your kitchen. If so much flavor moves into the water, why doesn't the color? Flavor molecules are tiny and dissolve completely, making them invisible. Pigments, which give fruit its color, are often larger and less water-soluble. Most stay trapped inside the fruit cells, so the water remains clear. Sometimes, if you crush berries or use ingredients like hibiscus, some color escapes. But with simple sliced fruit, the color usually stays put. You get a drink that looks pure, but tastes exciting. It's the difference between flavor compounds and pigment compounds. The science of solubility keeps your water clear and flavorful. That's why your infused water is a hidden surprise. Next time you sip infused water, remember the invisible science inside your glass. Tiny flavor molecules have traveled from fruit to water thanks to diffusion and osmosis. Your nose and tongue work together to create the full experience of flavor. Science isn't just in labs. It's in your kitchen, your garden, and your daily life. Understanding the why behind everyday things adds wonder to the world. Stay curious, ask questions, look for answers, and enjoy discovering hidden science everywhere. Every question is a new adventure in learning. The world is full of invisible wonders waiting to be explored. Here's a toast to curiosity, to the tiny molecules that make our drinks delicious, and to the science that makes life interesting. When you make infused water, you're running your own experiment. You're an everyday scientist, exploring the wonders of nature. Cheers!